Okay, so now we're going to talk about finding the zeros of a function. When we say finding the zeros of a function, we're really just talking about this f of x equaling 0. And so if we were to rewrite it, it'd be 0 equals x minus 1 times the quantity of x plus 2. And how you would handle that is you'd make each one of these products here, each one of these factors equal to 0. So x minus 1 would equal 0, right? X minus 1. And then x plus 2 would also equal 0. And then you would just solve for x. For both of these equations. Now, that may look very familiar to you, and that because we did something very similar when we were doing graphing. But when we were graphing, we didn't call it finding the zeros. We said find the intercepts, because when when y is 0, that's where the parabola intersects on the x-axis. So when we're talking graphs, we call it the intercepts. But when we're looking at a function, or I can just simplify it, say an equation, we could say it's called finding the zeros. We don't really say we're finding the intercepts. We may sometimes say that, but really it's not the right vocabulary. We should be saying finding the zeros when it's a function. So that is how you do it. It's a pretty simple concept. I want to do a few more examples, though, just to show you how it can be mixed up a little bit. So let's see. So find the zeros of each function. Looking at this one right here. The first thing you may notice is it's beginning with a negative. And remember, the f of x is going to equal 0. So we're going to factor out, and there's a GCF. The greatest common factor, what can go into all these terms, right? Be a negative 2. So what would we have left? Is it x squared? We divide all these by negative 2. Negative 2 divided by, or negative 10 divided by a negative 2 would be a plus 5x plus 6. But this also could be factored. What multiplies to 6 but adds up to 5? If you want, you can use your X box here to help you. So the answer would be 0 equals a negative 2 times, and this would be a 3 and a 2, so x plus 3 times the quantity of x plus 2, and then again set them all equal to 0. Negative 2 equals 0. Well, we know that's not true. Negative 2 doesn't equal 0, so we just ignore that one. X plus 3 equals 0, and x plus 2 equals 0. So you would subtract 3 from both sides, and x would equal a negative 3. Subtract 2 from both sides, and x would equal a negative 2. And that's the zeros for this function. So let's go ahead and do the next one. Looking at this here. So this one actually, if you were to multiply it, wouldn't be a quadratic. It wouldn't be a parabola. It'd be a cubic, which we'll talk about probably next video or maybe the video after. But notice that just for right now, notice you can factor this one. So 0 equals x minus 1. This is a square. This is a square, and there's a negative. The difference of two squares, x plus 4, x minus 4. You would set them all equal to 0. X minus 1 equals 0. And basically, when you're doing that, you just do the opposite of all these terms. So x would equal 1, x would equal a negative 4, and x would equal a positive 4. So I have another one here that's just a little bit different. Oh, by the way, in that last one, you may have noticed, so go back to it, that there were 3 answers. Sometimes there can be 3 answers, especially if it's cubic. Okay, if it's to the third power, if it's a turd. So looking at these 3, notice that in these 3 terms is a GCF again of 3. 0 equals 3. Divide each of these by 3, and you have each term, you have an x squared minus 4x plus 4. And then if you want, you can do your x box to help you factor this. what multiplies to 4 but adds up to a negative 4, a negative 2, and a negative 2, right? Negative times negative is a positive, adds up to the negative. So the answer would be 0 equals 3x plus 2 times the quantity of x minus 2. And so the answer would be, the zeros of this function would be a negative 2 and a positive 2. So remember what I'm saying here is that if I were to graph this one, where it hits on this y-axis, would be a negative 2, 1, 2, and a positive 2, 1, 2. That's the zeros again are the same thing as the intercept, the x-intercept. It's where the parabola is hitting the graph at those points. Okay, so next thing I want to talk about is using the characteristics to graph and write quadratic functions. So if you look at something like this, you can see right away the function's already in standard form, right? Going from highest exponent to lowest. You may know that it's opening upward because the a is a positive. It's greater than 1 or greater than 0. You can see that the y-intercept is negative 3. Do you remember from before that if x is a 0, then you have the y-intercept? Maybe I'll just show that real quick. It's been a while since we talked about that. So if the x is a 0, not the y here, but the x, you'd have h of x equals 0 squared minus 2 times 0 minus 3. Well, 0 squared is just 0. Negative 2 times 0 is 0. What you're left with is just the height, negative 3. So when you're doing the y-intercept, or if you're making the x equal 0, the k, this last number here will always be the answer. And so if we were to graph that, let me get a graph out here. If we were to graph that, it would be the y-intercept, the x is 0, and y is negative 3. And how that would look is if y were 0, when it go up or down, I'm sorry, the x is 0. When it goes sideways, the y would be negative 3. You just go down 3. So that would be 0, negative 3. That's the y-intercept. That gives us some data on a graph. Not bad. This blue's looking a little blurry. I'm going to change colors there. But how do I get the other points on there? We can do the same thing. We tried the y being 0 and we got this, or the x being 0 and we have the y-intercept. Well, let's find the zeros then for the other one. So to find the zeros, we're going to make this h of x equals 0. And then you try an x box. Well, multiplies to a negative 3 but adds up to a negative 2. The negative 3 times 1. So it's 0 equals x minus 3 times the quantity of x plus 1. We just set them both equal to 0, and so x would equal 3, and x would equal 1. And so on the same graph where we did the y-intercept, we now have these x-intercepts, where x is 3, 1, 2, 3, and x is 1, 1. And you can see that we have some of these points here on the parabola here. You know what? Let's see something real quick. Oh, I made a mistake, didn't I? Let me see. I did make a mistake. I should have took the opposite. this is a negative 3, this is a positive 3, this is a positive 1, this should be a negative 1. So instead of being a positive 1, it should have been a negative 1. This should not be here. So graphing this, though, I have the y-intercept, I have 2 points. It's good. It's good. I can already start to graph it. So just with that, I can start to graph it. I have at least 3 points using these zeros for the x-intercept and the y-intercept. Now, obviously, to get a more precise graph, I would need to find the vertex, which we've talked about extensively in these other videos. That's pretty much what we focused on. I think I'll stop here. We've kind of covered a lot of ground, and we'll continue next time.